Okay, good evening, students. We are discussing today our monthly test paper, our first monthly test paper for 2027 A-level students, which we kept in this February month. Okay, so this paper is asking questions up to energetics and S block. And yeah, there were 25 MCQs and two structured essays and two essays. So today I'm hoping to discuss with you the MCQ paper, right? So we will go to the paper and start our discussion. Okay, so this is for 1 hour, right? Uh, the first question is asking the set of quantum numbers represented by is representing what type of an electron. Okay, so the quantum numbers are 2, 1, 0, and plus half. Okay, so it is given in order. So we write the quantum numbers in order of n, l, ml, and ms. So the values given 2, 1, and 0, and plus half. Okay, I'll quickly explain what it is. Okay, so there are 4 quantum numbers. The first quantum number represents my energy level. Okay, energy level. So according to this, so this is in the second energy level. Second energy level, second main energy level. Okay, and then our second quantum number L, we call it as azimuthal quantum number. Okay, azimuthal quantum number represents the shape of the orbital, or we can say the if you put these two together, we can say it is showing you sub-energy level. Okay, so there are possible L values. L value can be 0, 1, 2, 3 like that. And the sub-energy levels will be, the shapes of the orbitals will be, types of the orbitals will be S, P, D, F like that. We can continue. Okay, so here it is 1. So P sub-energy level. So if you put these two together, okay, it will exactly tell you which sub-energy level. It is a 2p sub-energy level electron. Understood, Lamai? That's where the question lies. Okay. So we don't need these ML and MS values for our answer, but however, ML stands for magnetic quantum number, which is representing the orientation of orbital. In other words, you can say the exactly which orbital we looking in. So for example, if it is 2p, you have 3 orbitals, no? So we can label them as -1, 0, and +1. Okay, so like that. Here is the middle orbit. And this one MS spin quantum number, which represent actually the spin of the electron. Okay, here it is clockwise spin. So like that, we have done plenty of questions from this topic, so no need to tell the same thing again. So however, answer for our question will be the third one. It is a 2p electron. It is a 2p electron. So to your review, describe this quantum set. Okay, and if you got wrong here, let's say you got wrong for this question, so then go through the theory part again and do some questions from the same topic again. Okay, because there are enough papers we have done, so by now you will be able to revise this whole topic if you want with proper number of questions. Right, next the second one is asking this X belongs to the which group of the periodic table. Okay, right, and I'll quickly put the structure in the board. So it is X forming 2 single bonds and 2 double bonds with oxygen. 2 double bonds with oxygen. So they have marked the lone pairs for oxygen, but they haven't put any charge. They haven't put any charge. And they have given you the overall charge of this ion as minus. Okay. So now how should we think about this question? So now this oxygen in this way carry a formal charge of -1. Okay, and this oxygen should also carry a formal charge of -1. There will be no charge for this, right? So however, the overall charge of this whole thing is -1. That means if we take the charge of this one as n, okay, so n plus Okay, -1 plus -1, -1 plus -1 will be equal to the overall charge -1. Okay, so if you simplify, you will notice that n is going to be what? +1. Understand? So that means here you have a +1 charge. Here you have a +1 charge. Understood? Then Lamai, then go to this formula you learned in second unit. Second unit. Remember the formal charge formula? Formal charge equals number of valence electrons minus, okay, number of lone pair electrons minus half of the number of bond pair electrons. Okay, bond pair electrons. Okay, so the valence electrons of this one we don't know. Let's label it as Nx. And the formal charge for this one is +1. And there are no lone pairs, so 0. And number of bonds, here you have 1, 2, 3, 4, 5, 6. 6 bonds are there. So that means 12 electrons. So 12 into half. And you can simplify and find the value for x. X is equal to +7. So there are 7 valence electrons for this element. So then it is very easy. What is this group? It should be group 17. Understood, Lamai? In group 17, you have 7 valence electrons. Okay, for example, group 17 elements, let's take chlorine. What is the electronic configuration of chlorine? Condensed configuration, neon times 3s2, 3p5. See, here you have 7 valence electrons. You can give an example. Okay, so it is group 17. Okay, so these questions are kind of, this is the kind of a past paper shadow question. I don't remember exactly which year, but this similar question was there. And I have seen this question frequently in term test papers also. So it's a good theory to understand. Okay, so how to do the question? Find the formal charges and of the internal atoms and equal the whole charges to the overall charge. Then you can find the charge of this one. Then apply this formula. You don't need the formula actually, you can think and understand this too. Right? I hope it is clear. Then we can go to the, let's see the answer. The answer for this question is answer 1. Okay. And the next one, here you have a small printing mistake. Right? It should be ClF4 plus. Okay, ClF4 plus. Okay, ClF4 plus. So it is asking the electron pair geometry and the shape of this ion. Okay. Right. So chlorine is our central atom, and there are 4 fluorine atoms as peripheral atoms. Okay. So now if you add the, let's follow the usual Lewis method for this one, just to reminding purpose. And the chlorine carries 7 valence electrons, and there are 4 fluorine atoms. So will be 7 into 4, 28. And there's a positive charge, so you have to subtract 1 electron. Total number of electrons will be 28 plus 6, 34. From that 34, you have to subtract 8 electrons for the bonds. Okay, so that means 26 electrons are there. So 13 electron pairs. 13 electron pairs. So if you distribute these electron pairs starting from fluorine, you need to use 12 electron pairs for fluorine. The remaining electron pair you can put to the chlorine. Okay, so chlorine will have one electron, one lone pair. Okay, and then you can check the formal charges around chlorine. You will notice it is +1. Okay, so 1 electron is missing. 1, 2, 3, 4, 5, 6. Chlorine should have 7 electrons. Okay, Laman, is that clear? So this is the Lewis structure of the molecule. So without the Lewis structure also, without the Lewis method also, you can get the same answer. Right, so what is the electron pair geometry and shape? What is the electron pair geometry and shape? So here you have repulsion units around chlorine. So how many repulsion units? You have, Lamai, 5 repulsion units. So 5 VSC PR units. So if there are 5 VSC PR units, electron pair geometry should be trigonal bipyramidal electron pair geometry. And there must be only, there's only one lone pair. No? So it should be seesaw shape. Seesaw shape. So if you are properly drawing the molecule, then it should be like this. So fluorine, and there's a lone pair and another fluorine. This is the proper geometry of the molecule. Understood, Lamai? But in this question, the trigonal bipyramidal part is not there. So anyway, there's no proper answer for the question. However, if you add that by part to the question, you can select answer 1 and answer 1 and 5 both. So I think the bipyramidal, that word is missing by mistake. Okay, Lama? So anyway, just review the question. Nah? That's our target here. Okay, then these 3 questions were kind of easy. Now let's go to the 4th MCQ. 4th MCQ. So it is asking about, yeah, the de Broglie wavelength. Okay, so the question is about de Broglie wavelength. Question is about de Broglie wavelength. Okay, see, a particle moves with the kinetic energy E and wavelength lambda. What is the kinetic energy of this particle when it moves at 4 lambda wavelength? Okay, so our de Broglie equation, lambda equal h over mv. H over mv. Okay, and here you don't have kinetic energy. You have, in the place of, in this place you have speed. Okay, so now anyway we'll plug kinetic energy into this formula and modify this. So what is the kinetic energy formula? Kinetic energy equal half mv square. Half mv square. Okay, so now we can get a proportionality relationship. Okay, so lambda inversely proportional to speed. Okay, and here you can say kinetic energy is directly proportional to speed square, and therefore speed is directly proportional to the kinetic energy root. Kinetic energy root. Okay, so in the place of this speed, here we can place what? Kinetic energy. Kinetic energy root. Okay, so simply we can now say the relationship between wavelength and kinetic energy. Kinetic energy. Is that clear? So here, if they are, according to the theories we learn in gases, we learned about direct proportionals, inversely proportionals in gases, right? So if they are inversely proportional like this, we know their product is a constant. So that means lambda 1 Ke root 1 is equal to lambda 2 Ke root 2. Understood? So this formula we can finally derive. Okay. So now let's apply and see. Let's apply and see. It is asking, yeah, the first one it is lambda and E naught, E root, first situation. And then the substitution is, it is 4 lambda. 4 lambda. And they're asking, what is this new? Let's label it as E2. E2. Okay, so then you need to get this square of the both sides, then the lambda get cancelled. E equals 16 E2. So therefore your E2 is equal to E over 16. Okay, E over 16. So answer is answer 3. So there are, you can think and get the answer also, but anyway, I prefer for you, because you are still beginners, I prefer this, writing method. Okay, so answer is answer 3. So can I see how many of you got this answer in the exam? Answer 3. Can I see a hand raise? Okay, good. Good. Okay, very good. Now let's go to the question number 5. Question number 5. So it's simply fourth question. You can see derive the relationship and get the answer. Okay, and I forgot to mention, you can derive the relationship right here also. Okay, you can say the inversely proportional lambda 1 over ke 2 root is equal to lambda 2 over ke 1 root. So this is also the same equation, right? Can apply that too. Right. So anyway, let's move into the fifth question. In the fifth question, it is asking, in the following molecules, which one has the highest number of atoms in the same plane? Okay, highest number of atoms in the same plane. So there are 5 molecules. We'll draw all those 5 quickly and find the answer for this question. So first one is PCl5. PCl5. In PCl5, it is a trigonal planar molecule. So if you remember the shapes, geometries quickly, you can see now, you can do this question faster. Okay, you can do this question fast. So it's trigonal planar molecule. So there are 4 molecules, 4 atoms at the same plane. See, 4 atoms at the same plane. So 4. Then go to the next molecule, SO3. SO3 is a trigonal planar molecule. So all those 4 atoms are, because they are in the same plane, so we mark them by the dotted line. So here again you have 4 atoms in the same plane. Okay. Then the next one is SF6. SF6. In SF6 it is an octahedral molecule. An octahedral molecule. You can see these 4 atoms and the middle sulfur atom, they all in the same plane. So there are 5 atoms in the same plane. So right now this is the one with the highest value. Okay, let's wait and see. Then you have SF4. SF4 is a seesaw shaped molecule. Seesaw shaped molecule. Okay, and yeah, you can see now there are only 3 atoms in a given plane. If you consider this plane also, you have 3 atoms. This plane also, you have 3 atoms. So it's not enough, right? And then the last answer, BRF3. BRF3, it is a T-shaped molecule. T-shaped molecule. So practice more, Lama, you will remember like I'm telling here. Okay, when I'm writing the formula, I just know it is T-shaped. So like that, with the practice, you also can come to that level. Okay, so you can get these 4 are in the same plane in that way. So still it is 4 atoms. So this will be our answer, the one with 5 atoms in the same plane. Okay, so these questions you have to do fast. Okay, quickly get into the answers because you need to save time to do some calculation questions there. It will take more time. Okay, so do these questions fast. That's my advice. So repeat similar questions and increase your practice and your timing and everything you can develop. Okay, right. Now let's go to the next question. Sixth one is asking a small chemical calculation question linked with gases. Okay, this is a good one. I think we did the same question in our class. Okay, so anyway, you might remember that one. Let's try this and see. Let's try this and see. Okay, so here there's a reaction. There's a reaction. The reaction between ammonia and oxygen. Ammonia reacts with oxygen to give NO gas and water vapor. So you know the reactants and products, so you need to balance this one using inspection method. We'll do it later. And then it says 8 atm of NH3. 8 atm of NH3 reacts with 8 atm of O2, atmosphere of O2. So this is a unit that measure pressure. So here they have given the pressure. And it says it is a rigid container and 300 Celsius. Rigid container, and 300 Celsius temperature. Okay, so now these data are enough for us to start and do the question. Okay, right. The first thing, we'll balance the reaction. We'll balance the reaction and see. So here, Lama, you have one nitrogen, three hydrogen, like that. Yeah, the first thing we can do, we can balance hydrogen. Here you have two hydrogen. So let's put here 3. Let's put here 2. Okay, and then you have to put 2 over here, and altogether you have 5 oxygen atoms. So here it should be 5 over 2. So now it is a fraction. With this fraction we can do the question, but still let's remove the fraction by multiplying the whole thing by 2. And this becomes 4. This becomes 4, and this becomes 6. Okay, so the ratios are, stoichiometry ratios are 4:5:4:6. Okay, right. So balancing the reaction is the first one. Then Lamai, think about this data. So they are not giving you moles, right? So they are giving data about 2 reactants. Okay, so this is supposed to be our added reactor remaining ARR method question. But we typically apply ARR method for what? We are applying it for moles. But in this question, you can see there are no moles. They tell the data in terms of pressure. So then what is the theory behind this? How do you match that? So that's why these 2 points are important. It is telling rigid volume. So that means volume is constant and the temperature is also remain constant. Now for gases, we apply PV equal nRT. Go to that equation and see RT is anyway a constant. Volume is a constant. Therefore, you can say pressure is directly proportional to what? Moles. So instead of moles, you can use pressure for this question. That's right. Okay. So instead of moles, you can use pressure for this question. Understood? So now just think this as moles and do the question. You will get the answer. So anyway, it is 4:5 ratio. So now 8:8. So 8 and 8 moles are added. So you can see here, this is the one that is fully consuming, right? And the total 8 moles of this one will, not moles, ATM will react with this one. And how do we find how much of this will react? So the method I told you is divide by its own stoichiometry and multiply by the required stoichiometry. Remember, divide by the own stoichiometry 5, multiply by the required stoichiometry 4. So then if you divide this one, it will be 1.6. 1.6 into 4, 6.4. 6.4. Okay, and here 6.4 will be 4 because it's the same form. And here it is 1.6 into 6, 7.2 ATM. Okay, so the remaining here, nothing remains, is the limiting reactant. Remember, limiting reactant. And here 1.6 will be remaining. So what is the question they're asking? I think they're asking the final pressure. Yeah, the final pressure. For the final pressure, the P total is given by the partial pressures of each gases. So simply you need to add the pressures of these gases. Pressures of these gases. Understood? Pressures of these gases. So it's 300 Celsius. So obviously water is a vapor. And here there's no pressure from water. And you can simply add the 1.6, 6.4, 7.2. Okay, so 15.4. Wait. Yeah. 13 plus 4, 15.2. 9.6. There's a mistake I did. No, Pute? Here it is not 7.4. It is what? 1.6 into 6. So 36. It is 9.6, not 7.2. 9.6. 9.6. So then here, when you're adding them, what is the answer? 6. And there's 1 here, 10, 17.6. 17.6, 18. But unfortunately, Lamai, that answer is not there. That answer is not there. Check the answers. It is 17.4. So anyway, I gave all for this question. But I know most of you will be marking this answer. Okay. Right. So that is the method. Remember well, chemical calculation and gaseous state knowledge, both are necessary. Okay, the next one is about gases. It's a theory question. We'll see. Which of the following statements is correct regarding gases? So first one says mean square speed of an ideal gas is directly proportional to absolute temperature. Mean square speed of an ideal gas is directly proportional to absolute temperature. So about ideal gases, we have kinetic molecular theory. In that kinetic molecular theory, last point is about this average kinetic energy. It is equal to 3 over 2 RT. Okay, RT for mole and KT for molecule. K is the Boltzmann constant molecule. Remember this one? So then according to this, mean square speed. Mean square speed, okay, not this equation. There's another equation, right? Before deriving this, C square bar equal 3 RT over capital L. And this is mean square speed. And there is another one, C square bar root, which we call as CRMS. That is equal to 3 RT over capital M root. Now here, in this question, they are asking about the mean square speed. So mean square speed then of a given gas, if it is a given gas, capital M is constant. Given gas. M is constant. And then you can say this one, C square bar is directly proportional to the temperature. It should be absolute temperature. So in the question, it is telling as absolute temperature also. So you can say the first statement is correct. Okay, now let's see why other statements are wrong. Understood? How many of you got the first statement as correct? Can I see a hand raise? Okay, good. So now look at the second statement. Let's see why it is wrong. Gas can be liquefied when only given pressure. It's wrong, right? You can liquefy gases by cooling also, right? By cooling also you can liquefy gases. Remember our phase diagram? Phase diagram in between pressure and temperature. You can draw the phase diagram. Okay, here you have the critical point, triple point, and this is your solid, liquid, and gas. So a gas can be liquefied by cooling also. Let's say this is a gas. So if you cool, it will progress towards this direction. Can you see? By cooling also, by lowering the temperature also at the same pressure, you can liquefy that. Okay, so therefore, the second statement is wrong. Second statement is wrong. And the third statement is telling for ideal gases, pressure inversely proportional to the volume. For ideal gases, pressure inversely proportional to the volume. Okay, how do we explain that? So pressure and volume relationship is given by a gas law. What is that gas law? It is Boyle's law. Boyle's law explains the relationship between pressure and volume. Pressure and volume. It says pressure is inversely proportional to the volume of the ideal gas, but there is a condition when temperature and moles are constant. These two must be constant. But in this statement, are they telling about these two? Look at the statement. For ideal gases, pressure is inversely proportional to volume. That's the only thing they say. But this statement is wrong. Because why? This will be inversely proportional only when temperature and moles are constant. Understood? Only when temperature and moles are constant. Okay, so therefore third statement is wrong. Now look at the fourth one. Under the same conditions of temperature and pressure, equal volumes of ideal gases do not contain equal number of moles. So do not contain is wrong. So it do contain. Okay, so right in front of that one, Avogadro law. Avogadro law. According to Avogadro law, they have equal number of moles. Understood? And then you can write the Avogadro law in your review. Avogadro law says this exact thing. And we discussed a few things about Avogadro law. And what we use for calculation is one thing. But Avogadro originally said something very similar to this statement. He talked about number of molecules. Okay. Right. Anyway, look at the last statement. Why it is wrong. At low pressure and high temperature conditions, real gases become ideal. Okay, it's wrong. Low pressure and high temperature are good for ideal behavior. So that doesn't mean the real gases become ideal. Understand? Real gases not become. Underline the word become and say wrong. Behave like ideal, not become ideal. Okay, they behave like ideal. So you need to focus on every word in this kind of a question. Okay, not become, behave like. So that's why the fifth statement is wrong. Okay, Raman, that's why the fifth statement is wrong. I hope you all understood that MCQ. It's a good MCQ from gases. Okay, so the papers that I'm giving you has a very small number of easy questions only. Most of the questions you can see in the paper are really good. So don't worry about your marks only. Don't worry about your marks. All these papers are exam level papers. So you have to improve up to that level. So I'm always showing you where to go. Okay, so practice and practice, then little by little try to improve the marks. Okay, so then eventually when you come to the exam, A-level exam in 2027, right, you will reach that necessary mark. Okay, so until that you need to keep trying. Okay, keep trying. Don't think for a second I can't do this. You can. You can. Okay, first of all you need to crawl before you walk. No? Remember. ඔක්කොම එකපාර වෙන්නේ නැහැ, right? We'll see. Now, the next one. Question number 8. Which of the following has the highest solubility in water? Okay, I just, when I'm checking the papers to add questions to your paper, I just see this question, so this question, and it's a really good one. So where this theory coming from? It is coming from your S block. S block. Remember S block? We discussed several sections. And one topic was there about solubility rules. Solubility rules. So you need to answer this question using that theory. Okay, using that theory. So the answer for this question is answer 3, magnesium sulfate. Magnesium sulfate. So what is the theory? What is the theory for this one? So the theory is this one. Theory is this one. So in soluble rules, remember the 8th rule. It was a table. Hydroxide precipitates and sulfate precipitates, and there were 2 other precipitates. Okay, for the second period elements, magnesium 2 plus, calcium 2 plus, strontium 2 plus, and barium 2 plus. These are the elements. These are the elements. Okay, so the thing is, hydroxide precipitate, magnesium is a very good hydroxide precipitate. But its solubility downward the group increases and barium hydroxide become completely soluble. So the opposite follows for the sulfates. Okay, magnesium sulfate is a soluble compound. Soluble compound. Soluble compound. Okay, and these are the sulfate solubility downward the group decreases, or the precipitation ability increases. Barium sulfate is a very good precipitate. Understood, love? So that's why it says magnesium sulfate has the highest solubility. So answer 3 is the one you have to take. And I'll say why others are wrong. So barium sulfate, as you can see, here it is a very good precipitate. So answer 1 is wrong. And from this one also you can say answer 5 is also wrong. Magnesium hydroxide is also a good precipitate. And what about the other two? Other two. So the thing is, you have to go to the seventh rule. In seventh rule, it says all carbonates and phosphates are insoluble. Only sodium, potassium, rubidium, cesium. Usually these group 1 cation precipitates or compounds are always soluble. Only these are soluble, but all others are insoluble. Insoluble. Okay, so then you have two carbonates, and the answer 2 and answer 4. Therefore, 2 and 4 are wrong because they are carbonates. Understood, Lamai? That's how you explain. So revise S block. Right now we are doing D block and energetics together. Okay, so these weeks I'm kind of completing the energetics part because we learned a specific, important D block area. So we need to revise it these weeks and while completing the energetics theory. So in this March, from day after tomorrow, we will be having the new month. So in this month, next month, we will be doing another monthly test paper. Before that paper, we will finish our discussion. Okay. So anyway, in that paper, in that month, we'll be finishing this energetics unit and the D block unit properly. Okay, properly, right? So hopefully I'll be keeping the exam at the end of the month so I can completely ask questions from up to D block. Okay, so revise, take your time and ask your doubts and everything. So you know lamai, what is that? We need a pass to the A-level exam because you all can get that, okay? You all can get that. That's what I'm telling. එහෙම වෙලා නේද අපිට පුළුවන් වෙලා අපි එක කරේ නැත්තම් නේ it's a අපරාධයක් right? So let's work towards that. Okay? Right. Yeah, the Google Classroom, one of your friends is asking to update that one. Yes, I forgot to do that. Anyway, I'll update that Google Classroom recordings. I think I added up to 20 or something. So now we have done few papers after that. So I'll add the recordings and answers, everything to that Google Classroom too. Okay, now come to the question number 9. It's also a good question. X and Y are elements in the elements of the same period and they form molecules XF3, YF4, which which of the following can be X and Y? So they are same period elements. What are the formula? XF3 and YF4. XF3 and YF4. Which of the following elements can be X and Y? Okay. Now the thing is, Lamai, it's not that difficult. Go with your answers. First one is telling sulfur and chlorine. Can it be sulfur and chlorine? Sulfur and chlorine. So SF3. Is there something called SF3? No. Why? The thing is, if you calculate the number of electrons, you will get an odd number. Odd number means single electron will remain on sulfur. It is not stable. Okay. So electron sum should be an even number. Then only when you get the pairs, you will have no unpaired, you can say unpaired electrons, single electrons. Okay. The thing is, single electrons can exist on there, but not in these molecules. So, for example, NO, NO2, they will have single molecule, single electrons. That's a single electron on nitrogen. See, this can happen, but not for these elements, sulfur chloride. So therefore, this answer is wrong. And then you can go to the second answer. Second answer is telling oxygen and nitrogen. So anyway, oxygen can't form OF3 because it will violate the octet. No? And third answer, boron and nitrogen. BF3 is there. Okay. And NF4, NF4, there's no such a thing. So it is also wrong. And fourth one, NO, NF3 is there. OF4 can't be there, Putri. Why? In these cases, OF3, OF3 and yeah, NF4. There's no such a thing anyway. So OF3 and OF4, they all are violating octet rule. Violate octet rule. Understood. So the only possible explanation is chlorine and sulfur. Chlorine and sulfur. So ClF3 is there. We draw another similar molecule. Remember BF3 or something we drew, and it is a T-shaped molecule. T-shaped molecule. And the other one is SF4. SF4 is a seesaw-shaped molecule. Remember, seesaw-shaped molecule. Seesaw. So these two molecules are actually existing. So the possible answers are chlorine and sulfur. Answer 5. Can I see a hand raise? How many of you got answer 5 for this question? How many of you got the answer 5? Okay, good. Okay, now let's go to the next question. Question number 10. Question number 10. Here it is a small chemical calculation. It's telling a sample of an alloy contain magnesium and aluminium in 1:2 ratio. It reacts with 50 cubic centimeters of 0.4 hydrochloric acid. So hydrochloric acid reacts with both these metals. Okay, so we'll explain that properly. It's a good question. HCl can react with both these acids. Okay. And the remaining volume of certain gas, 60 centimeter cube of 0.2 sodium hydroxide was required to neutralize the remaining solution. They're asking what is the mass of aluminium in this sample. Okay, so magnesium reacts with HCl to form magnesium chloride and H2. So it's reacted in 1:2 ratio. Then aluminium reacts with 3HCl to form AlCl3 and H2. But for balancing purpose, we need to add like 6 and 2. Then only it will get balanced. Okay, so here it is also 1:3 ratio. Okay, so here they are telling Lamai something important. The molar ratios of magnesium to aluminium is 1:2. That means if from magnesium you have X moles, from aluminium you have 2X moles. Is that clear? 2X moles. So that means here you will react 2X and here you will react 6X moles. 6X moles. Understood? So altogether you have 8X moles of HCl. Right? 8X moles of HCl. And they are telling added HCl and remaining HCl you can find there. So let's find moles of added HCl. Added. So you need to multiply 0.4 mole per decimeter cube by 50 centimeter cube. 50 into 10 to the power minus 3. So you'll get 4 into 5, 20. 2 into 10 to the power minus 2 moles. Okay, and then they says there's a reaction happening between NaOH and HCl. It's an acid-base reaction which happens in 1:1 ratio. Okay, so then you can say moles of sodium hydroxide used for that finding remaining HCl. So moles of sodium hydroxide is 0.2 into 60. 0.2 into 60. So 1, 2 into 6 is 12. So you can see 1.2 into 10 to the power minus 2 moles are there. So therefore, remaining HCl should also be the same value, no? Remaining. That is also 1.2 into 10 to the power minus 2. So now you know the added value and you know the remaining value. You can find the difference. Okay, so therefore, HCl reacted with metals. Simply, you need to get the difference. 2 minus 1.2 into 10 to the power minus 2, so 0.8. You can say let's write 0.8 first. 0.8 into 10 to the power minus 2. That means, Lamai, this is equal to, let's bring that one up here. 8 into 10 to the power minus 2, let's write 8 into 10 to the power minus 3. It's equal. So therefore, the x is equal to 1 into 10 to the power minus 3 moles. Understood? In that way, you can get the value of x. And it's asking the mass of aluminum. So mass of aluminum, be careful, it is 2x. 2 into 1 into 10 to the power minus, it is the moles, and multiplied by the relative atomic mass or relative molar mass. Okay, molar mass, 27. So it is 54, 0.054 grams. Yeah, answer is answer 2. Be careful with the simplifications too. Okay, can I see a hand raise? How many of you got that answer? 0.54 after calculating. Okay, very good. And you need these reactions, Lamai. I believe if you got into trouble with the question, that's because of the reactions. Okay. So remember, any metal, not any actually, active metals can react with the dilute acids and form hydrogen gas. Okay, so that's the 10th question. Let's go to the next question. 11th one. So it's from energetics. See, this is the first energetics question we can see here. And after this, you have, we have 3 energetics question in row here, 11, 12, 13, which are very good to revise this energetics topic. Okay, right, we'll see. So there are 2 thermochemical reactions equations given. So it's asking what is the correct one? What is the correct one? Okay, now let's find out the correct one and say why others are wrong. Look at the first one. 1 mole of the first reaction. Where for 1 mole of the first reaction, 218 kilojoules of heat is absorbed. So that is wrong, Lamai. Why? It is minus 218. Minus means it is exothermic, releases. Okay, so not absorbed. It must be released. So underline the word absorb and say it is wrong. It should be released. 218 kilojoules of heat is released. So first one is wrong. And look at the second one. They are kind of adding 2 reactions and giving you an answer. So we'll do the same thing and see. Write the 2 reactions. It is A plus 3B goes to 2C. There is one reaction and enthalpy change of that one is minus 218 exotherm. And the second reaction is 3D goes to C. Enthalpy change of that one is plus 74. So now if you want to get that unknown equation, Lamai, A plus 3B goes to 6B, you can see C is missing. C is missing. So what should you do? So multiply the second equation by 2 and add to the first equation. Add to the first equation. So first equation is A plus 3B goes to 2C. A plus 3B goes to 2C. And if you multiply the second equation by 2, and you need to reverse that 2, right? Forgotten. reversing and multiplying by 2. Okay. If you reverse the second equation and multiply by 2, it should be 2c and 6d. So now if you add, you can see 2c get cancelled. A plus 3b goes to 6b. So now here you need to do the same thing for the enthalpy changes. It's minus 74 into 2. So it will give you minus 148 minus 218. So what will be the answer? 16, 1, 6 and minus 366. Understood. But what they are telling you, it is 70 kilojoules of heat is released. No, not 70. It should be greater than that. So you don't need to do the calculation to find this, tell this one is wrong. So when I'm doing the paper, I didn't use that. I didn't calculate the value. Why? Because here, when you think that you need to reverse the second equation and multiply by 2, okay, you will notice that reverse reaction, when you get the adjust the second equation, it will become minus. So when you're adding the two equations, it should be a negative value more than 280. You have to think like that. Okay, so then this answer is not greater than 200 something. No, it is just 70 kilojoules. So it is wrong. In that way, you can say the second statement is wrong without doing any calculation by just a small, simple thinking. Okay. Right, now go to the next third statement. The 1 and 2 both are wrong. Okay? Go to the third statement. It says for 1 mole of C produced in the first reaction. Okay, so it is for 2 moles of C. It is for 2 moles of C when they are asking for 1 mole of C. So if you want the 1 mole of C, you need to divide the equation by 2. So same thing will happen to our enthalpy change. So it should be also divided by 2. So it will become 109. It says 109 kilojoules of heat is evolved. Evolved means exotherm. Okay, now it is okay. So third answer is correct. Yeah, answer is answer 3. And now let's see why fourth and fifth answers are wrong. You can write, you can write something for the third answer. Say about this. Divide by 2. So it will become half A, 3 over 2B, and C. Then your enthalpy change will be minus 218 over 2, minus 109. Like that, explain a bit. It will be good for your knowledge. And fourth and fifth answers. Fourth one, look at the fourth one. It says 2C goes to 6D. You have reversed the equation and multiplied by 2. It is 148. Yeah, it is 148, but not plus 148. It is minus 148, Lama. Do you remember? We did it. It is minus 148. It says positive. It's wrong. It's a good question, right? And look at the last statement. For 1 mole of C production in the second reaction, 74 kilojoules of heat is not evolved, but it is absorbed. Because in the second reaction, it is plus 74. It is plus 74. Understood, Lama? So you can easily explain. It's a good theory about thermochemical equations. Can easily explain. Our third one is the answer, is the correct one. And when you are writing the reviews, please add why other statements are wrong. Okay? That is important. Okay. Now let's go to this 12th question, 12th MCQ. So it's a thermochemical equation addition method, no? You have to adjust these 3 equations given and yeah, you have to get this unknown equation settled. Right, now let's see how to do it. Let's see how to do it. And your unknown equation is carbon monoxide reacts with 2H2 to form CH3OH liquid. Okay, I'm going to skip physical state because there's no same compound or element with the two physical states here. Okay? So same physical states now. So they're asking the enthalpy change of this value, this one. Okay, now tell me what to do with the first equation. In our first equation, it is carbon monoxide is there in the left side. So here we have only one carbon monoxide now. So we can say divide the first equation by 2. So when you divide the first equation, it will become carbon monoxide, half O2 goes to carbon dioxide. Enthalpy change will also be divided by 2, 566 division 2. Okay, and then think about the second equation. According to the second equation, it should be reversed because methanol is there in the right side. Second equation should be reversed now. See, this methanol is there in the right side. So when you reverse the second equation, they become carbon dioxide then to water, arrow, CH3OH liquid, and O2. So when you're reversing the enthalpy change, reversing the equation, enthalpy change sign will be reversed. Now it will become plus 750. And finally, we have to think about the hydrogen. Here you have 2 hydrogen, but in the equation you have only 1 hydrogen. So third equation you need to multiply by 2. So it will become then 2H2 and O2 goes to 2H2O. Okay, so now let's add these 3 equations, the one that we modify. Here, wait, we need to multiply this one by 2. No? Minus 286 into 2. Okay, here you can see 2 water will get cancelled and carbon dioxide will get cancelled. Half O2, yeah, this O2 get cancelled, half O2 will remain, and you have carbon monoxide. Wait, when we are multiplying by 2, is that 1 O2 is getting cancelled. Half O2, O2, carbon dioxide, yeah, 1 oxygen isn't it balancing? Carbon monoxide, H2, methanol, and half O2, I think, when you are reversing this, and you are multiplying this, and you divide by 2. Okay, I think something is missing in the question, right? Okay, what's with the half O2 thing, Lama? Should get cancelled, ne? So anyway, if you simplify this one, you will get, minus 140, okay? Minus 140. Minus 140. So let me check one more time what happened to the oxygen. What happened to the oxygen? Okay, so here, now let's go from the beginning. It is carbon monoxide and O2, and we divided the equation by 2. We divide the equation by 2. The given equation is balanced. We need to check that too. Then it will become this equation. Okay, we can understand. And then go to the next question, second one. Carbon dioxide, 2 water, CH3OH, and yeah, oxygen. Here. That's the mistake. Here, Pute, oxygen is not balanced in the given equation in the question. That's why oxygen is not getting cancelled. Ne? CH3OH, that's a mistake in the paper. It's not O2, carbon dioxide, then 2 water. So now here you have total 4 oxygen atoms now, right? But in this side you have 3 oxygen atoms. So it should be not O2, 3 over 2 O2. That 3 over 2 part is not there. So that's why. So then if you add 3 over 2, then this half oxygen will get also cancelled. Because 3 over 2 is 1.5. That 0.5 is here. Can you understand now? Please correct your paper. If you have the paper with you, correct that one. It should not be O2. It should be 3 over 2 O2. 3 over 2 O2. Anyway, you can get the answer properly. Don't worry. Yeah, how many of you got the answer? I think answer is 2. Minus 140. Okay, good. Good. Okay, now let's go to the third question. Came from energetics. Now another topic we concluded in January is defined enthalpies. Defined enthalpies. So now here it is asking combustion, standard enthalpy change of combustion, formation, everything are given, and they're asking you to find the enthalpy change of this equation. Okay, let's try to solve that problem. So now it's given combustion of carbon. Combustion of carbon. So combustion of carbon, what is the equation? Carbon graphite solid reacts with O2 gas to form carbon dioxide gas. So this is the combustion equation. The enthalpy change is minus 394. And the next one, formations of carbon monoxide. Carbon monoxide formation, the reference element is graphite solid. And you need half oxygen. The formation enthalpy minus 110. Formation of carbon monoxide. And you can see something interesting here, Naman. Now this combustion of carbon is equal to formation of carbon dioxide. Ne? You can tell that too. Same equation. Okay, write it as a different additional fact. And then again, formation enthalpy change of water gas. Reference elements are H2 gas and half O2 gas. Then the enthalpy change for this reaction is minus 242. H2O. Understood. Now you need to use these three equations. Now if you can figure out this is to be as formation enthalpy. So they all are formation enthalpies. Ne? They all are formation enthalpy. So you can use that equation addition method. But since they are formation enthalpies, we can use a specific cycle, right? Remember, specific method we can use. Because this unknown equation, you know all the formation enthalpies of these entities. Formation enthalpies of these entities. And especially for this one, we know it is a reference element. So formation enthalpy is 0. And how do you find this enthalpy change? Start from the reference elements. So what are the reference elements for this side? Carbon graphite solid, and O2 gas, and H2 gas. H2 gas. Okay, so then you can form this one, carbon dioxide, or you can say combustion of carbon. You can say same thing, minus 394. And here formation of this one minus 110, water minus 242. So now you can apply Hess's law. This path enthalpy change sum is equal to this path. Path 1, path 2. So according to the Hess's law, delta H, let's say this one is delta H. Delta H plus minus 394 is equal to minus 110 plus minus 242. So if you simplify, you will get this answer they have given plus 42. Plus 42. So have to be careful with the simplifications, Lama, because yeah, there's a minus 42 also. Understood, Lama? So can I see how many of you got the answer 3 for this question? Answer 3. You can use thermochemical cycles, normal addition method also. Okay, good. You can label these 3 equations. You can label these 3 equations and change their directions and get the answer. You can do that too. Okay. Right. Now let's go to the 14th MCQ. 14th MCQ. That is from gases and a good theory. A good theory. What is the temperature at which the mean square velocity of SO2 gas is equal to the mean square velocity of O2 gas at 27 Celsius? Okay, let's revise that part. Okay, it is mean square velocity again. Mean square velocity, or you can say speed. Speed is the proper word. C square bar. That is equal to 3RT over capital N. It's not root, only not root. So you can say yeah, they're asking at which temperature they are equal. Okay. So then C square bars are equal. So then we can say, let's say T1 over molar mass of O2 is equal to T2 over molar mass of SO2. This equation you can derive using that because it says the speeds are equal. And then you can say it is SO2, the first one. Yeah, anyway, it's fine. It is 27 Celsius means 300 Kelvin. And this O2 molar mass is 32. But don't substitute 32 here. For this equation, Lamai, molar mass should be in kilogram per mole. Because it is derived using SI equations. Kilograms per mole. But the thing is here, when we get both in kilograms per mole, that unit thing will get cancelled. Okay, so example 32 into 10 to the power minus 3 kilogram per mole. In the other side will also, it will be 64 into 10 to the power minus 3 kilogram per mole. So that error to error get cancelled. So don't worry about that one. But anyway, when they ask, especially to use this equation only, or this, let's say they give these values and asking you the C square, then you need to remember what I said. Okay, it's an important point. And let's label this as T temperature T2. You can see they are easily cancelling. This will be 600 Kelvin. Should be needed higher temperature. Ne? And from this 600 Kelvin, subtract 273, you'll get 327 Celsius as your answer. Okay? Yeah, it's a good question. Good question. Okay, Lama, I hope you all understood that one. And then we are coming to the next question, 15th one, the best MCQ in this paper. Okay, so there was a small mistake. It should be MO, not 2 plus. Here it should be MON plus. Okay, so in basic medium it says M2 plus ions get oxidized to MON plus ions. Okay, in the presence of sodium hydroxide, in the basic medium this happens. And in the presence of sodium hydroxide, and the oxidizing agent is KMnO4. So in basic medium, MnO4 minus reduces to MnO2. MnO2. So you need to be given that one. But however, when we are balancing redox reactions, you know this. And in D block, you will properly learn this. Okay. So this is what happens. This is what happens. And they have given the KMnO4 volume and concentration, 40 centimeter cube, 1.25 mole per decimeter cube. And it says capital M2 plus concentration and volume are also given, 25 centimeter cube, 1.2 m solution. Yeah, what is the value of N? That's what they are asking. Okay, so now let's see how to do it. It's a good question. Huh? Like I said, it's a very good question. So now let's start with the help of permanganate. So what is the oxidation number? Here it is +7 and it reduces to +4. Okay, so now if you balance it, MnO4 minus accept 3 electrons in the reduction to become MnO2. So now for balancing we need OH minus. So here is -4, so I add 4 OH minus and 2 water for the balancing. Then in the both sides you have 6 oxygen atoms each. So it's correctly balanced. Okay, correctly balanced. Now from this we can find out the moles, no? Moles of permanganate. Moles of permanganese is 1.25 into 10 to the power minus 3 into 40. So now if this amount is 1.25 into 10 to the power minus 3 into 40, what will be your electron moles? 1.25 into 10 to the power minus 3 into 40 into 3 moles of electron. So now in a redox reaction, you have very important principle. Remember that one. When someone oxidizing, other one should undergo reduction. So let's say when there are this amount of electron moles are needed for the reduction, that same amount should be given out by our M2 plus metal. Remember, M2 plus give that same amount during oxidation. Okay, so that means you can now get the ratio between M2 plus 2 electrons for this equation. What is the M2 plus moles? 1.25 into 10 to the power minus 3 into 25. Sorry, 1.2, 1.2. And to this, and you get the electron ratio. 40 into 3. So now we can simplify and see the simplest ratio. Here, get cancelled. 25 to 125, you have 5, 0.05. And then here you can cut 0.4. And this also can be cut 0.1. So here Lama, 0.1 to 0.5. That means 1:5. 1:5. That means this E is accepting, so this M2 plus is accepting 5 electrons. You can write this as an equation. M2 plus, not accepting, only releasing. M2 plus releases 5 electrons and become MON plus. MON plus. Understood now? MON plus. So what should be the oxidation state? Here it is +2 And the oxidation number here should be plus 7. Plus 7. So now let's consider this part and apply oxidation number method. Okay. So 7 plus -2 for the oxygen is equal to N. N is the charge. So it is 5 plus 5 plus 5. They're asking just the value. It is 5. Is that clear, Lamai? Can I see how many of you got that answer? It was a good question. Huh? This is the method you need to write it. Yeah, I can see. It's okay. It's okay. Now learn the method. I'll give you a minute to absorb it. So do it properly. Okay. Yeah. Now let's go to the 16th MCQ. We have 10 more MCQs to finish. We'll do them quickly. It's a kind of a usual question asking what is the proper order of electronegativity increasing? Electronegativity increasing. So they all are carbon containing compounds. So you need to apply scope rule. Scope rule. Okay. We'll discuss how to apply. So what is this scope? S percentage, charge, oxidation number, and peripheral atom electronegativity. So if these properties are increasing, what will happen to your electronegativity? Electronegativity will also increase. Scope. Okay, scope. Right. Now we can go to the molecules. CCl4 is the first one. CCl4. And the next one is CF4. They both are tetrahedral molecules, no? So S percentage is 25%, 25%. Why? Because the hybridization is sp3. Only one orbital out of 4 is s, no? So 1/4 is 25%. And then you have CH4, it is also the same. 25% is character. Then you have CH2F2, that is also the same. 25% is character. And finally, you have something different, COCl2. In COCl2, it is trigonal plane. So sp2, 1/3, 33.3% has this character. So this should be the one with highest electronegativity. Highest electronegativity. Okay, so that your answers should be ending with COCl2. So answer 4, answer 3 are wrong. You can eliminate 2 answers. Then you need to go to the charge. You can see all these carbon atoms are having no charge. So we can't decide electronegativity based on charge here. Don't look at this one, okay? You already identified its location. Now worry about these 4. Then get the oxidation numbers. Here it is more electronegative chlorine element is there. So it is +4, +4, -4, and 0. Okay, because why? Because carbon is more electronegative than hydrogen. So it will pull 2 electrons from hydrogen. And for fluorine, carbon will lose 2 electrons. Get 2 and lost 2. So that's why it became 0. So now, these are the higher values and this is the lowest value. So they should be in the 5th place. This should be in the 4th place. And this should be in the 1st place. Highest value. Then we have a doubt between this chlorine and fluorine. Then you need to go to the last point, peripheral atom electronegativity. If peripheral atom is more electronegative, then it will have more electronegativity. So therefore this will be in the second place and this will be in the third place. Understood, Lam? That's how you find the answer. I kind of said it quickly because we have done it the number of times in this same paper class. So what is the answer? Starting from CH4, you have two answers. And it is answer number 5. Answer number 5. How many of you got that answer, Lamai? Answer 5? Can you see hand raise? Okay, good, good. Yeah. Now let's go to the 17th MCQ. It is from S block. It's asking false statement. First one says all elements in S block react with dilute acids violently. All elements in S block. The word is violent. The violent word is somewhat doubtful because magnesium, when magnesium react with dilute acid, it is not that much violent. It's a fast reaction, but it is not violent. Okay, so underline the word violent and say wrong. Magnesium, beryllium. Okay, write this statement. Magnesium and beryllium are not reacting violently. They react steadily. Okay, they react steadily with dilute acids. Magnesium and beryllium. Okay? The first two elements in group 2. They are originally low reactive. No? If it is for group 1 elements, this statement is true. Okay. Now, anyway, they are asking the false statement. So, this first one is going to be one of our answers. Okay? Look at the next one. All elements in group 1 except lithium reacts with N2 gas. That is also clearly wrong. So, if you are asked to mark an answer in the exam, you need to select the second statement. Because why? It is totally wrong. Except lithium react. It's not. Only lithium reacts. All others are not reacting with N2. Only lithium reacts with N2. So second statement is also wrong. And it is the most suitable answer. Okay. Answer 1 and 2 both are wrong. And both are answers. Look at the other 3 statements. They are correct. Anyway, we'll discuss a bit. Third one says all elements in group 2 reacts with N2. Yes. Okay. Beryllium, 2, barium, they all react with N2. Okay. To form metal nitride. And fourth one says sodium react with excess oxygen to give you peroxide and potassium gives you superoxide. That part is also correct. And remember the formula of superoxide and peroxide. Okay. So when we since we studied that one in the class, students remember the name. Okay, but sometimes you may face a trouble if you forget the formula. Okay, so study the formula too. Last statement, all elements in S block are good reducing agent. That is correct, Lama, because they undergo oxidation. Okay, so themselves undergo oxidation. Therefore, they are good reducing agents. For example, sodium and potassium, they lose electrons during their reactions. That means they undergo oxidation. That means sodium is a good reducing agent. Okay, it's a good question. Huh? So we did many of the similar questions. So try them. And now let's go to this 18th question. It's asking, which of the following is correctly represent the ascending order of the property indicated in the parenthesis? Yeah. Second ionization energy. Okay, we'll discuss that in the board. Yeah, beryllium, boron, and lithium. This is the order. You have lithium, you have beryllium and boron. This is for the IE1. So when it comes to IE2, you have to come one backward. Remember? Because it assumed the previous element's configuration. So this comes here. So it is boron plus beryllium plus and lithium plus will be somewhere here. It's very higher value. And because it will take the noble gas configuration. Okay, take for example lithium to lithium plus. Here it is 1s2, 2s1. But from lithium plus to lithium 2 plus, the second ionization is very difficult. Why? Because if you release that 2s2, here it is 1s2. It is a very stable noble gas configuration, helium configuration. That's why this value is very high. Understood? So the proper order is lithium is the highest. Then you have boron. Finally, you have beryllium. So this is statement A is correct. Understood, Laman? A is correct. It's about second ionization energy. Then look at the next one, radius. Radius. This is kind of my one of the favorite points. This was asked in 2020 level MCQ also. So remember, anion radii are larger than neutral atoms. Neutral atoms. Okay, so when we say that, please remember, anions like N3 minus, O2 minus, F minus are larger than their parent atoms. Okay, that means F minus is larger than N. Remember that. So your B statement is wrong because it is kind of following the other way around. Okay, so B is wrong. Okay, now go to the C statement about electronegativity. These elements in our there's electronegativity order. Remember, FOClN, FOClN, BRI, SCPH, like this. So in this order, you can see out of the 4 elements given, 3 are there. Nitrogen is there. And then sulfur is there. Okay. Hydrogen is also there. But in this order, can you see silicon? Where is silicon? Silicon is not belonging to this series, Lamai. Why? Silicon is a metal. Metal. So it has metal, non-metal in between characters. So they all, here what we write, they all are non-metals. So that means correct order is silicon should have a low, because it is having sort of metallic properties. So should have a low electronegativity. So the correct order is silicon, hydrogen, sulfur, and nitrogen. Okay, so answer C is also wrong. Understood, Laman? Answer C is also wrong. Then go to the last statement. Negative value of the first electron gain energy. You know, there's a theory point. Eg1 negative value decreases downward the group 1. Okay, so this value, this one is correct. So the highest negative value is there for lithium, sodium, potassium, rubidium, like that you can take cesium. So why it is happening in that way? Why the negative value decreases? Negative value means it is exotherm. So negative value decreases means, Lama, it becomes less exotherm. Less exotherm. Why it becomes less exotherm? Because here you can see the radius is a smaller one. But when it comes to cesium, it is relatively very large. So now the new electron and the nucleus will have a very large gap. Okay, so therefore this electron is less attracted to the nucleus. less attracted to the nucleus. Due to higher distance. That's why electron gain energy is low. It will not release that much energy because it is less stable. Understand? So when you add in the new electron to here, there's one electron in this shell, and if you're adding another one here, then there's a large gap. So that's why downward the group 1, Eg1 negative value decreases. So remember, it's a very good MCQ point. Highest negative value Eg1 negative value from group 1 is lithium. So that's a MCQ point. And our D statement is also correct. And then they're asking the correct statements. So answer is going to be 1 and A and D. Answer 4. How many of you got that answer correct? Can I see a hand? Okay, very good. It's a good question, huh? Okay, go to the question number 90. It's about cathode ray and anode ray experiments. Okay. Cathode rays and positive rays cannot move a paddle wheel in the place of their when placed in their path. That is wrong, Lamai. Both cathode rays and anode rays are having particle character. So say this statement is wrong. First one is wrong. Okay, Lamai. First one is wrong. And the second one, okay, they can move a paddle wheel. Okay? Second one, since positive rays are positively charged, they show equal deflections in magnetic fields. That is wrong. The positive ray deflections are unique to their gas. Okay, because their positive rays type may be different. No? If it is hydrogen gas in the tube, positive ray is H plus. Right? If it is oxygen gas in the tube, it may be O plus, O2 plus, like that. So you can obviously see H plus and O plus, their masses are different. Okay, so their masses are different. Now let's say here O plus is there, it's heavy. And here let's say it is H plus is there, it's lighter. So when this is coming, if you apply a magnetic field, this will bend, or in an electrical field, are they using magnetic field? The magnetic field, let's say the magnetic field is, you are giving, some magnetic field lines are into the plane. So when electricity comes in this way, they will move upward. And that upward movement is low, right? It is low. And do not need the direction, the upward or downward, whatever. We need the angle only for the A levels. And this one will have a higher deflection angle. This one will have a lower deflection angle because of the lighter weight. This has a higher deflection angle. Remember, okay? So A was wrong, but B is also wrong, eh? Yeah, B is on. The A is correct, ne? It says can move paddle wheel. Yeah, I forgot. I interpreted that wrong. So it is Pudha, actually it says can move a paddle wheel. Let's see that one again. Cathode rays and positive rays can move a paddle wheel. Yes. They can move a paddle wheel. That is correct. And B is wrong. B is wrong. So they don't show equal deflections. They show different angles. And look at the C statement. Although positive rays are a beam of particles having mass like cathode rays, it's wrong. Positive rays and cathode rays are having different masses. You know, positive ray mass of positive ray particles is larger than mass of electron. Okay, if you take this is like, this one is 1840 times large mass of H plus. Okay, so they do not have wave property. That part is also wrong. They have wave properties. It's depend on their size. Because electron, proton, those things are very small. Positive ray, they are very small. So they can show particle as well as wave behavior relative to their size. So, golf ball, bullet, they can't show wave properties. Why? Because their speed, because relative to their size, their wavelength is very, very small. Okay, very, very small. So we will not observe that. 10 to the power minus 30 something, the wavelength. So it's not a very observable value anyway. It's very, 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 very small. So everything has a wave property. But the thing is, for macroscopic objects, you can't observe it because wavelength is very, very low. For microscopic objects like electron and others, you can, we can't observe by our naked eye, but we can experimentally observe that. Because their wavelength is relatively larger relative to their size. Okay, anyway, the last statement says they are traveling in straight lines. That is correct. D is correct. You can confirm that one right there. Confirmed using metal cross, remember? It will give you a clear shadow of the metal cross. Clear shadow of the metal cross. Okay, so answers are A and D. Answer 4 again. Answer 4. Okay, so now for new batch 2028 A level, we are starting these lessons in this week. Okay, this Sunday we are starting the first class at Nugegoda branch. And next week the other areas we are starting classes and online classes, everything. So if you missed any lessons during your period, so you can attend these classes. Okay, just let us know in advance. We can arrange it. So you can participate the classes and cover the necessary lessons. Okay. So anyway, we are starting unit 1 and unit 3 together, just like I did for you. And it is very productive, because chemical calculations is good to do from the beginning. So we'll do some, not the redox and other parts, just the simple O-level and A-level gap we need to bridge now. So therefore that chemical calculation is a good area to start. Okay. And I think I put my timetable to your groups, Lamai. And yeah, if you are having any siblings or some relatives or someone who ask them to come. Okay. And just let them know the times. Right. Now let's go to the next question. Question number 20, the last ABCD question. It says, which of the following statement are true about an atom with sp hybridization? Sp hybridization. Okay. Now let's come to this sp hybridization. First of all, take some examples. BeCl2 is having sp hybridization. Then carbon dioxide is having sp hybridization. CO2. See, sp hybridization. Those are examples. And then ethine is another one that is having sp hybridization. They all are sp hybridized. Why? Because they are linear. 180-degree angle and sp hybridized. Okay, so now focus on these examples and give answers. Look at the first one. It says, always there are two VSCPR pairs. That is correct. Of course, that's why it was linear in the first place. Then look at the D. It says it can form a triple bond. Can form a triple bond. Yes, it can form a triple bond. That is correct. Correct according to ethyne. Now, near the in your paper, you can draw ethyne. And C, always 2 sigma bonds should be formed. Always 2 sigma bonds. 2 sigma bonds. sp hybridization, true about an atom. 2 sigma bonds should be formed. Always 2 sigma bonds are formed, right? Here you can see. This is a sigma bond and this is a sigma bond. That is correct. Always 2 sigma bonds are. No. Wait. And what about this one? This is a peripheral atom. So this peripheral atom is also considered as sp2 hybridized. Hybridized peripheral atoms. Peripheral atoms do not make 2 sigma bonds. Okay, so therefore this C statement is wrong. So write about that one specially. I know some of you might take it as correct. I also was going to take that as correct, but I just suddenly remember this. Okay, what about D? D statement is wrong anyway. It is having a printing mistake. Always at least one 5 bond is formed. That is wrong because of BeCl2. Okay, it says always one 5 bond is formed. No. Okay, 5 bonds are not compulsory. So can you understand, Lamai, how we answer the question? Just remember some examples you came across during the lesson. Using them, tell these statements are correct or wrong. That's the method. That's the method you have to follow. Understood, Lamai? So answer is answer 5 anyway, because this is having a printing mistake. If there was no printing mistake, or sorry, answer was all, all. And if there was no printing mistake, answer C and D are wrong. Answer A and B are correct. Answer will be 1. So explain about that. Correct the statement. Here it should be not A, it should be 5. Okay, so now let's move into our last 5 MCQs. Those are true-false MCQs. First one is about radius of potassium plus iron. Radius of potassium plus iron is greater than the radius of sodium atom. So it's wrong, Lamai. First one is wrong. Why? So if you take potassium plus, what is the electronic configuration? 1s2, 2s2, 3s2, 3p6. Because it was 4s2, 4s1 earlier, 4s1 electron is removed. So it has 3 energy levels. If you get sodium atom, 1s2, 2s2, yeah, 2p6 is missing. 3s2, 3p6, okay? So for sodium atom, 1s2, 2s2, 2p6 and 3s1. So it also has 3 energy levels. Right? So the number of energy levels are same. Number of energy levels are same. But potassium plus has more effective nuclear attraction, FEFF. Effective nuclear attraction, let's say nuclear attraction. More nuclear attraction. Therefore, size will be lower. Okay, so they both have 3 energy levels. 3 energy levels. Now, if they say like this now, sodium is smaller than potassium, that is correct. But sodium is larger than potassium plus. So remember this as a fact. It's a good point to study. Effective nuclear charge of sodium is higher. No, it's wrong. effective nuclear charge, its formula is ZEFF equal Z minus sigma. Okay, so don't worry about sigma. Just think about the Z. Number of protons. Ne? Here Z is 19, here Z is just 11. Ne? Sodium is not having a higher value. Okay, so it's wrong. So both are wrong. Answer is answer 5. Both are wrong. Answer is answer 5. Second are wrong. So answer is answer 5. So how many of you got that answer? Answer 5. That's a good question. Can I see a hand raise? Answer 5. Okay, anyway. Yeah, good. Now this 22. When an endothermic reaction occurs in an isolated system, temperature does not return to the initial value. That is correct. Why? In an isolated system, Lama, it is kind of trapped from, there's no heat, work, matter exchange from with the outside. It is fully isolated. So now let's say there's an endothermic reaction happening. So A2 goes to 2A. So energy is absorbed, no? To break the bond. To break the bond, energy is absorbed. So as a result, you put a thermometer here, temperature will decrease. Temperature will decrease and it will not return to the initial value. The graph will look like this. Decreases and then stays with the time. But if it is an open system or closed system, remember the graph? It was decreased and returned to the initial value after some time. Open or closed system. Add them two, then good for the comparison. And then the next one says molar enthalpy change is extensive. Wrong. Molar enthalpy change, kilojoule per mole. Kilojoule per mole, when they express per mole, per kilogram, per centimeter cube, they become intensive. What are the intensive properties, Lama? The properties that doesn't depend on the amount of matter. Okay, so molar enthalpy change, when they say for molar, it is becoming intensive. Enthalpy by definition is an extensive property, okay? Enthalpy, no problem, it is extensive. But molar enthalpy is intensive, okay? Molar enthalpy is intensive. So answer is answer, first one, yeah, the first one is correct, ne? First one is correct here. And second one is wrong. So answer is answer 4. Sorry, 3. Yeah, then go to the question number 23. Question number 23. The properties of NO bond in one NO bond in NO3 minus iron is different from this of other NO bond. So it's wrong, Laman. Why? Because if you take NO3 minus, this is the Lewis structure. You put the lone pairs and everything, this will become the Lewis structure. This is the bond structure. And if you just think about this one, you might think the given statement is correct. Because you will see one is a double bond and others are single bonds. But remember, Lama, when they ask the questions like this, you have to focus on, think about resonance hybrid. Resonance hybrid. Hybrid, not this one. This is a resonance structure. So what will be the resonance hybrid? Resonance hybrid will be a combination of all its possible resonance structures. So for nitrate ion, there will be 3 resonance structures. There will be 3 resonance structures. So hybrid is a combination of these 3. So in that case, you can see partial 5 bonds are there because these 3 structures are equally stable. Okay, so You can't find a difference, difference in length or anything for the nitrate molecule, because the resonance structures are equally stable. As I remember, I did one very lengthy explanation by taking similar questions in an earlier paper. Just remind the lessons. At the time around we did the resonance, maybe September, August wage. Check the lessons lama. Theory class, the paper class recordings, you will find some good questions from this topic. Okay. And then the second statement says, nitrate ion has 3 stable resonance structures. That is correct. So first one false, second one correct. Answer is answer 4. Okay. First one false, second one is correct. Answer is answer 4. Yeah. Then you can go to the next one. It says average speed of O2 molecule and at 25 Celsius is less than the average speed of CO2 molecule at the same temperature. At the same temperature. Okay, now what is average speed? C bar. C bar is directly proportional to T over capital M root. T over capital M root. So if the molar mass increases, C bar will decrease. Okay, so you can say C bar of O2 gas is lower than, sorry, not lower, higher than C bar of CO2 gas. So look at the statement. O2 molecule is less than. So telling less is wrong. It will be higher than. So first statement is wrong. Look at the second statement. At 25 Celsius, both O2 and CO2 molecules have the it should be same average kinetic energy. That also in the same temperature. We wrote this equation early accidentally, remember? Is equal to 3 over 2 RT or KT. So you can see it is only depending on temperature, absolute temperature. So if they are having the same temperature, these two will have same average kinetic energy. So if some student thinking this way, or he or she will get answer 4. But there is another problem in the second statement. You can say second statement as false also. Why? Because that ideal word is not there. This equation is applicable for ideal gases. Ideal word is not there. Therefore, someone can say answer 5 also. So I give marks for the both. In A-level exam, they will clearly tell you whether it is for ideal or not. I consider ideal behavior, something they will mention. If it is not given, again, both options are okay. Understood, Lama? Both options are okay. Right. Then we come to our last MCQ. What is that? A gas cannot be liquefied by compression at a temperature higher than its critical temperature. That part is correct. Okay, that part is correct. And the second one says above critical temperature, liquid vapor equilibrium does not exist. Yes. So both the statements are correct. 25th one, both the statements are correct. And second one can explain the first also. So answer is going to be answer 1. I'll roughly tell you how it is happening. So this is your phase diagram. It's your phase diagram. This is your critical point, C. Okay, so here you have liquid, gas, solid. So your triple point, like it is temperature and this one is pressure. Right, so what is they are telling? If you compress after the critical point, now let's say here you have a gas. Now you are compressing it, keep compressing it, but you will not see the solid vapor equilibrium because it has stopped from here. But if you take a gas somewhere around here, if you continue to compress, after this it will become liquid. But here there's no liquid form. Because why? because liquid vapor equilibrium does not exist after the critical point. So you can give a definition for the critical point also by checking your note. Critical point is the maximum point where the solid liquid vapor equilibrium exists. After that, liquid vapor equilibrium disappears. Understood, Lama? So just remember these as facts. Study that gaseous state lesson. You can see several questions came from gaseous state. Maybe 6 questions were there. Okay, so anyway, I hope you understood everything really well. And if you have further doubts, you can always ask. I'm there to help. Yeah, and write a good review and bring this to our theory class. I'll check when I'm going around. I can check. Okay, Lama. So in next week we'll discuss our structured essay questions, and if time is there, we'll see to do essays as well. And anyway, be ready for the March monthly test also. By week we have enough months until our exam. So don't worry about your mark. Okay, so try to improve at least your mark by 5 at least. Okay, let's say you got 50 marks this time. Try to score 55 to the next month. Try to become at least slightly improved. Okay, right. And yeah, so that's it for today, Lamai. And goodbye. Study well. See you again in our next class. Okay, and good night, Lamai.